Right. Good day to you all. Right. Today අද මම කියලා දෙන්න යන්නේ ඔයගොල්ලන්ට collisions ගැන. Right. So today I'm going to talk to you about collisions that we discuss in our physics curriculum. Right. You can see collisions. Right. So there are three main types of collisions you can see: elastic, inelastic, and perfectly inelastic. So this is what we are going to talk about today. Right. So before going on to details in collisions, we need to talk about the theory part related to the collisions. Right. So what is the theory part which is related to the collisions? Now this we say is the conservation of linear momentum. Right. The theory part which relates to the collisions is the conservation of linear momentum. So when you are going to do questions, if they ask you to write the conservation of linear momentum, you need to be able to write this perfectly, right? Explaining every detail of the conservation of linear momentum. Right, so I'm going to write down the conservation of linear momentum. Right, it says that if the resultant force acting on a system towards a certain direction is zero, the linear momentum towards the same direction is conserved, or we can say constant. Right, මොකද්ද මේ කියන්නේ? මොකක් හරි සිස්ටම් එකකට කිසියම් ඩිරෙක්ෂන් එකකට තියෙන resultant force එක 0 නම් ඒ සිස්ටම් එකට resultant force එකක් නැත්නම් ඒ ඩිරෙක්ෂන් එකට එහෙනම් ඒ ඩිරෙක්ෂන් එකට තියෙන linear momentum එක conserve constant ඒ කියන්නේ වෙනස් වෙන්නේ නැහැ. ඒ ඩිරෙක්ෂන් එකට තියෙන linear momentum එක වෙනස් වෙන්නේ නැහැ. ඉතින් අපි බලමු කොහොමද මේක prove කරලා තියෙන්නේ. right, මේක කොහොමද මෙහෙම වුනේ? මේකේ proof එක. right, දැන් මම කරන්න යන්නේ මේකේ proof එක. right, මේක prove කරලා තියෙන්නේ ඉතින් Newton's second law of motion පාවිච්චි කරලා. ඒ කියන්නේ F equals ma පාවිච්චි කරලා තමයි මේක prove කරලා තියෙන්නේ. so අපි දන්නවා F equals ma කියන equation එක mechanics වල අපිට වැඩ ගොඩක් කරගන්න පුළුවන් equation එකක්. ඉතින් මේ equation එක apply කරද්දී we need to know that we always need to write the direction and to whom that we apply. කාටද කොහෙටද මේක apply කරන්න කියලා අපි අනිවාර්යයෙන්ම කියන්න ඕනේ. So when you apply F equals ma, you have to mention the direction and you have to mention to whom that we apply this equation. Right? So I'm going to say that applying F equals ma to a certain system to a certain direction, to a certain system to a certain direction, right? So I did not mark the direction here because you don't need to specify an exact direction. Make an example එකක් නිසා, because it's an example, right? So I can expand this equation F equals ma. A is v minus u by t. Expanding this furthermore, F equals mv minus mu by t. So you can say ft is equal to mv minus mu, right? So in this equation, this refers to the resultant force. So now I'm going to say if F is 0, if the resultant force towards that direction is 0, then I can say Ft product is 0. So mv is equal to mu. Now I'm not going to cancel off M2M, right? Instead, I'm going to write MV is equal to, or MU is equal to MV. So here I can say that initial momentum is equal to the final momentum. Initial momentum is equal to the final momentum, right? So we proved that the momentum, the linear momentum is conserved. මොකද දැන් අපි හොයාගත්තේ linear momentum කියන එක වෙනස් වෙන්නේ නැහැ කියලා. Right? So this proof is going to explain everything that we have written in words here. අපි වචනෙන් දීපු හැම දෙයක්ම මෙතන පෙන්නනවා. කොහොමද කියලා බලමු. If the resultant force acting on a system towards a certain direction is zero, the resultant force acting on a system towards a certain direction is zero. On a certain system towards a certain direction, if the resultant force is zero, then the linear momentum is conserved, right? මෙතන ඔය හැම දේම හරියටම කියවලා තියෙනවා proof එක. ඉතින් proof එකේ කරපු දේවල් ටික තමයි අපි වචන වලින් කියන්නේ. So if they ask, කොයි වෙලාවක හරි අපෙන් ඇහුවොත් මොකක්ද conservation of linear momentum, or to write the conservation of linear momentum, this is exactly what you should write, right? And if you miss any of these important words, you don't get marks, right? So we got to know what conservation of linear momentum is. Okay, so what we've been talking about is collisions, right? So I need to say that there are three types of collisions you can see: elastic, inelastic, and perfectly inelastic. Elastic, inelastic, and perfectly inelastic. හරිද? දැන් අපි කතා කරමු කොහොමද මේ collisions types තුන වෙනස් වෙන්නේ කියලා. There are elastic, or we can also say perfectly elastic, and inelastic, and perfectly inelastic collision. So what is an elastic collision, right? Let's see what is an elastic collision. The collision in which there is no energy loss. Energy loss එකක් නැති collision එකකට අපි කියනවා it's in elastic or perfectly elastic collision. There is no energy loss. The energy that we had before the collision is similar to the energy that we have after the collision. So no energy loss. So usually in a collision there is no significant potential energy loss. Potential energy කියන එක පුතේ ගොඩක් ලොකුට වෙනස් වෙන්නේ නැහැ. වෙනස් වෙන්නේ kinetic energy කියන එක. So අපි කියනවා initial kinetic energy is equal to the final kinetic energy in an elastic or in a perfectly elastic collision. So an inelastic collision is the opposite of an elastic collision. A collision in which there is an energy loss is known as an inelastic collision. ඉතින් පුතේ මේ collision එකේදී energy loss එකක් වෙනවා. Initial kinetic energy එක final kinetic energy එකට equal නැහැ. එහෙනම් ඒ equation එක අපිට මෙතනදී apply කරන්න බෑ. So we cannot apply that equation here. But for an elastic or perfectly elastic collision, we can apply the equation initial K is equal to final K. But in this one, we cannot. So then we will what is a perfectly inelastic collision. You may wonder what is that. So if there is an energy loss or not, yes, there is an energy loss. When you say inelastic, perfectly or not, what type of an inelastic collision it is, there is a kinetic energy loss. So here also initial kinetic energy is not equal to the final kinetic energy. So what is different between an inelastic collision and a perfectly inelastic collision? So let me tell you the difference. The difference is that after the collision, both objects, if you're talking about two objects in this collision, move together as one. After the collision, both objects move together as one. So, say that we have two objects of mass m1 and m2 before the collision. So this is before. And after the collision, what happens is that we don't have two, it's one object. Both of them will move as one object after the collision. දෙන්න එකට ගමන් කරනවා එක්කෙනෙක් විදිහට යනවා collision එක ඉවරනාට පස්සේ, right? So this is what we call a perfectly inelastic collision. The only difference is that both of the objects will move together as one in a perfectly inelastic collision. And also, පුතේ ඔයගොල්ලෝ දැනගන්න ඕනේ මේ ඕනෑම collision type එකකදී, so any of these collision types, you can apply conservation of linear momentum, right? You can apply conservation of linear momentum for any of these collision types. However, there is a condition. You can apply the conservation of linear momentum to any of these collisions under one condition, right? Under the condition of the resultant force to that direction has to be zero. If so, you can apply conservation of linear momentum to any of these scenarios, right? So now we know about collisions. So now we then ඉගෙන ගත්ත පුතේ collisions ගැන, right? What is the theory that we can apply? What are the equations that we can apply? And what type of collisions that we have, right? හරි. එහෙමනම් මම තව දෙයක් පෙන්නන්නම්. A few examples for collisions. A few examples for collisions. So Pute, I'm going to show you a few examples here. The first one is when a heavier mass, you can see the heavier mass here is the capital M mass. So a heavier mass go and hit a lighter mass elastically. So we are talking about elastic collisions here. So if a heavier mass go and collide with a smaller mass at rest elastically, so what happens after is that the heavier mass will continue to move towards the same direction it was moving, and the lighter mass, now you know in the collision what is going to happen. Now that also I will show you the collision එකේදී මොකද වෙන්නේ කියලාත් මම පෙන්නන්නම්. So when they collide with each other, මේ දෙන්න එකට හැපුණාම the heavier mass will get a force towards this side. The similar force we call action and reaction is going to act on the lighter mass. ඉතින් heavier mass එකට මේ පැත්තට momentum එකක් හම්බෙච්ච නිසා එයාගේ momentum එක අඩු වෙනවා. So V2 will be less than V1. V2 will be less than V1. And because that the lighter mass got a momentum towards right hand side, it will move towards right hand side, right? So usually what happens is that the heavier mass will not stop, or heavier mass will not bounce backward. It will move to the same direction it was moving before, right? So this is one example. And let's see what happens if it happens the other way. Right. So now we have the other scenario, the second scenario, where the heavier mass is at rest initially, and the lighter mass comes with a certain speed and hits the heavier mass. Right, so let's see what happens in this collision. So there will be two forces acting on each other, action and reaction. Since the heavier mass got a force towards right hand side, it will move towards right hand side. The lighter mass got a momentum towards left hand side. So what usually happens here is that the lighter mass bounces backwards. යා ආපු පැත්තටම ආපහු යනවා. මේක තමයි සාමාන්‍යයෙන් වෙන්නේ. Right? Now, I told you that these collisions here, they are elastic. Right. So the third example is when two identical masses collide. One mass collides with another mass which is identical and is at rest. මෙතනදී මොකද වෙන්නේ කියන එක මම දැන් ඔයගොල්ලන්ට කියන්නම්. This is what I got. So before, this mass m is moving towards the stationary mass m and elastically collides with it. So now I took that both will be moving to the same direction. But this is not actually what is happening. ඇත්තටම මේක නෙමෙයි වෙන්නේ. We don't know the values of V1 and V2. So we are going to find the values of V1 and V2. Right? So I'm going to show you how exactly to find the values of V1 and V2. Now in the previous two scenarios, I told you what happens exactly. මොකද වෙන්නේ කියලා මම හරියටම කිව්වා. දැන් මේ scenario එකේ මට හරියටම කියන්න බෑ. ඉතින් මම දැන් හොයන්න යනවා V1 and V2 using our collision knowledge. Collisions ගැන අපි දන්න දේවල් පාවිච්චි කරලා දැන් මේක හොයන්න යනවා. එහෙනම් මුලින්ම මම කරන්නේ conservation of linear momentum apply කරනවා. ඉතින් මම දැන් කියලා දෙන්නම් the proper way to apply conservation of linear momentum. So whenever you apply conservation of linear momentum, if it is not an MCQ, you have to always write applying conservation of linear momentum. I'll be writing everything in short form. So you have to write that you're applying conservation of linear momentum, and also it is very important to show the direction, because these equations are equations of vectors. Vectors equation ලියනකොට physics වල හැමතිස්සෙම අපි direction එක දාන්න ඕනේ. Right? So by using the direction, what we try to denote is that we consider that this direction is positive. Right? So initial momentum here is mv. Now this is equal to the final momentum mv1 plus mv2. So m's get cancelled. So what we get is v equals v1 plus v2. Right. So v1 we can write v1 is equal to v minus v2. මම v1 කියන එක පොඩ්ඩක් මෙතනින් එළියට ගත්තා. And you get to know why. මම මෙහෙම කරේ කියලා ඔයගොල්ලන්ට තේරෙයි තව ටිකකින්. Right. Now still we have no idea what v1 and v2 are. Now since this is an elastic or perfectly elastic collision, we can apply initial KE is equal to final KE equation. Initial kinetic energy, final kinetic energy වලට equal වෙන්න ඕනේ. So let's apply that and see what happens. Initial KE. Initially you have the simple m as only. So this is the initial KE. Finally you have both of them. So you have to write KE values of both of them like this. So here also half m are getting cancelled. So v squared is equal to v1 squared plus v2 squared. So I'm going to write, instead of v1, I'm going to put v minus v2. V minus v2 squared plus v2 squared is equal to v squared. Simplifying further, you can write v squared plus v2 squared minus 2vv2 plus v2 squared is equal to v squared. ඉතින් v squared උත් කැපිලා යනවා දෙපැත්තේ. So what you'll be getting is 0 is equal to 2v2 squared minus 2vv2 කියලා. ඉතින් මෙතන 2 වලින් බෙදන්න පුළුවන් equation එකම it's simplification method. So what you get is v squared minus vv2. මෙතනින් අපිට එළියට ගන්න පුළුවන් v2 එක. So that is v2 minus v into v is equal to 0. Right. So දැන් කවුරු හරි හයි, why can we not divide this by v2 and get v2 minus v is 0? බෑ. එහෙම කරන්න බෑ. So in maths, you know, if you have something like a into b is equal to 0, a into b is equal to 0 කියලා තිබුණොත්, how to solve this? So මෙහෙම තිබුණොත් එක්ක a 0 නැත්නම් b 0, එහෙම නැත්නම් a b දෙන්නම 0. a 0 වුණොත් b a ගෙන් වැඩි කරාම 0. b 0 වුණොත් a b ගෙන් වැඩි කරාම 0. දෙන්නම 0 වුණොත් දෙන්නම වැඩි කරාම 0. ඉතින් මේ වගේ එකකදී අපිට කියන්න පුළුවන් a equal to 0 or b equal to 0 or a and b both are equal to 0 කියලා. Right? So අන්න ඒක තමයි අපි දැන් මෙතනදී පාවිච්චි කරන්නේ. So we can say v2 equal to 0 or v2 minus v equals to 0. Right? So if v2 is 0, තමයි හොඳට බලා ගන්න දැන්. If v2 is 0, v1 is equal to v. Right? v2 minus v is 0 කියලා කියන්නේ v2 is equal to v. If v2 is equal to v, v1 is 0. Right? So we got two pairs of values. ඔන්න අපිට දැන් value pairs දෙකක් හම්බුණා. මොකක්ද? පළවෙනි එක තමයි v1 is equal to v and v2 equals to 0. දෙවෙනි එක තමයි v1 is equal to 0 and v2 is equal to v. Right. දැන් මේ දෙකෙන් කොයි එකද වෙන්න පුළුවන්? Which one of these is possible? Now the first mass comes and hits the second mass. මෙයා ඇවිල්ලා මෙයාගේ හැපෙනවා. එතකොට මෙයාට force එකක් හම්බෙනවා මේ පැත්තට. Force එකක් හම්බෙලා එයා නවතින්න පුළුවන්ද? Not possible, right? So v2 anyhow cannot be 0 because v2, that mass is getting a force by the collision. Collision එකේදී යාට force එකක් හම්බෙච්ච නිසා එයා 0 වෙන්න බෑ. So the answer which says that v2 is 0 is wrong. So this cannot be. Not possible. Not possible. This is not possible. So this has to be the correct answer. This is possible. So what do we get from this? What do we get from this is that when two identical masses collide, when one is at rest, the one which moved first is going to totally stop and transfer its momentum to the other one. ඇත්තටම මොකද මෙතන උනේ? මේ මුලින් ආපු එක්කෙනා මෙයාට එයාගේ total momentum එක transfer කරලා මෙයා නැවතුණා. මුලින් ආපු එක්කෙනා නවතිනවා. දැන් මෙයා යනවා අර එයාගේ momentum එක අරගෙන. හරියට නිකන් අපි අර රිලේ එකක් දුවනකොට බැටන් එක අතර දීලා නවතිනවා වගේ නේද? අපි රිලේස් අපි දුවලා තියෙනවා නේද? දුවනකොට මොකද කරන්නේ? දුවගෙන ගිහිල්ලා වටයක් ගිහිල්ලා බැටන් එක දෙනවා ඉස්සරහා ඉන්න එක්කෙනාගේ අතට දීලා නවතිනවා. අන්න ඒ වගේ වැඩක් තමයි මෙතන වෙන්නේ. right? මෙයා ඇවිල්ලා මෙයාගේ හැපෙනවා. හැපිලා මෙයා නවතිනවා. මෙයා දැන් යනවා. total momentum එක අරගෙන. So what we know about these identical masses when they collide, they transfer their total momentum. Right? හරි. ඔන්න අපි දැන් collision types තුන ගැන ඉගෙන ගත්තා. So So before winding up this video, I am going to show you how to do a few questions that we got in past papers. Past papers වල ආපු ප්‍රශ්න කීපයක් අපි චුට්ටක් බලමු හදලා අපිට හදාගන්න පුළුවන්ද කියලා. සහ මොන වගේ ප්‍රශ්නද past papers වල අපිට collisions වලින් හම්බෙන්නේ කියලා. So I'm going to show you two questions that we find from the latest years. One is from 2019 and one is from 2021. So usually every year we get one question from this type, collision. එක collision ප්‍රශ්නයක් ගොඩක් වෙලාවට අපිට කවුරුත් දෙකදී හම්බ වෙනවා. මම තෝරගත්තා 2019 question number 36. 2019 paper එකේ question number 36 එක මේකට තෝරගත්තා. මේ තියෙන 2019 paper එක. Right. So we are going to question number 36. Now let's see how do we do question number 36. Right, what they say in this question is that there are 4 metal balls, 3 are identical, right? The first 3 are identical, they have the same mass, and the fourth one has twice the mass of the others, right? So what happens here is that the first M mass, now this one here is projected towards the right hand side with a velocity v. V කියන velocity එකකින් මෙයාව මේ පැත්තට යවනවා. එතකොට මොකද වෙන්නේ? Now the first one collides with the second one, right? When the first one collides with the second one, මම මෙතන මේ උත්තරයක්ම ගන්නම්, right? I will take one of the answers to determine the answer, right? So this one will go with a speed v and will collide with the second one. Now what is going to happen? You know, we just learned that when that happens, this one will stop and this one will now move with the velocity v, and it is going to collide with the third one. So what is again going to happen is that this one will stop and this one will move with the same velocity v. Now this is going to collide with this one. So දැනුත් නවතිනවද? නෑ. දැන් අපි මේ collision එකට මොකද කරන්න ඕනේ? මේ collision එක අපි conservation of linear momentum plus kinetic energy equations දාලා මේ collision එක හොයන්න ඕනේ. So we have to work on this collision. මෙන්න මේ collision එකට අපි ගාන හදන්න ඕනේ, right? So before and after scenarios, let me draw them here. This is before. And after what happens, අපි දැනට හොයාගෙන තියෙනවා. What should after happen is that this should go to this side. It's the lighter mass. So that will call V1 and this is V2. Right, so this is what happens after. So I'm going to get some space here. So I'm going to erase these answers. Right, so let's apply equation. So first of all, I'd like to apply conservation of linear momentum to this side. Initial momentum is mv is equal to 2mv2 minus mv1. m's get cancelled here. m's ටික කැපිලා යනවා. So we can say that v1 is equal to 2v2 minus v. Then we can apply the conservation of energy because they are elastic collisions. Initial kinetic energy is equal to final kinetic energy. So initially that is half mv squared. Finally it's half m v1 squared plus half into 2m v2 squared. So half m's get cancelled. what we get is v squared is equal to v1. Instead of v1, I can apply this now. So that is 4v2. Simplify කරලමයි මම මෙතන ලියන්නේ. 4v2 plus v squared minus 4v2 plus 2v2 squared. So here also v squared gets cancelled. මෙතන v squared එක මෙතන v squared එකට කැපිලා යනවා. Right? And what we get here now is that 0 is equal to 6v2 squared minus 4v2. So we can divide this by 2, the whole equation. And we can get a v2 out. So when you get v2 out, what you'll be getting is 3v2 minus 2v. So here is again something that we got, like a into b is equal to 0. So either a has to be 0 or either b has to be 0 or both has to be 0. So one answer is that v2 is equal to 0 or 3v2 minus 2v equal to 0. So if v2 is equal to 0, v1 is equal to minus v. If v2 is equal to 0, v1 is equal to minus v. Here we can say v2 is equal to 2v by 3. If so, v1 is equal to, බලමු කීයද ඒකට එන්නේ කියලා, 4v over 3 minus v. So that is v by 3. So this doesn't seem to be possible. That v2 becoming 0 is not possible. So we can say that this is a wrong combination and this can be the right combination. Right. So now what happened? ඔන්න දැන් අපි බලමු මොකද වෙන්නේ කියලා. Right? දැන් අපි හොයාගත්ත මෙතන මොකක්ද වෙන්නේ කියලා නේද? ඔව් මොකක්ද උනේ? 2m කියන එක්කෙනා දකුණු පැත්තට යනවා. 2m කියන එක්කෙනා දකුණු පැත්තට යනවා. 2m goes to the right hand side with a speed of v2, where v2 is 2v over 3. And m කියන එක්කෙනා වම් පැත්තට යනවා with a speed of v1, that is v over 3. Now m is going to get collided with again this m. එතකොට මොකද වෙන්නේ? එයා සම්පූර්ණයෙන්ම එයාගේ එනර්ජි එක ට්‍රාන්ස්ෆර් කරනවා මෙයාට. දැන් මෙයාට හම්බ වෙනවා v over 3. දැන් මෙයා ගිහිල්ලා මෙයාගේ හැපෙනවා. දැන් කලින් ආපු මෙයා නැවතිලා ඉන්නේ. Is that stop? Now this goes and collides with this one. So what happens? This one will again stop and this one will begin to move with the same speed v by 3. So these are the two final velocities and these two are now at rest. So which will give us the situation is the answer number 4. So fourth answer is the correct answer for this question, right? Okay, so I think you understood this really well, right? පුතේ දැන් හැමෝටම මේක තේරෙන්න ඕනේ. දැන් මේක තේරුනේ නැත්නම් ආයෙ පාරක් මේ වීඩියෝ එක බලන්න ගාන හදන ගමන්. පුතේ දැන් අපි බලන්නේ question number 6 in 2021 past paper එකේ question number 6. So to make up collision ප්‍රශ්නයක්, we can see that question number 6 here. Right, when you read this question, it says a block of mass capital M moving at a velocity 2v. A block of mass capital M moving at a velocity 2v on a flat frictionless surface makes a perfectly inelastic collision with another block of the same mass. So we have another block of the same mass at rest, and they collide perfect inelastically, right? Moving at a velocity v along the same direction. So this also has a velocity v, right? They're asking what is the velocity of the first block after the collision. What is the velocity of the first block after the collision? Now you can clearly see that you've been deceived in this question. ඔයගොල්ලන්ව රවට්ටනවා මෙන්න ප්‍රශ්නේ. Perfectly inelastic කියලා කිව්වහම අපි අහන්න ඕනේ මෙහෙම නෙමෙයි ප්‍රශ්නේ. What is the velocity of the combined object? Because now you don't have two objects. දැන් object දෙකක් තියනවාද? නෑ. දැන් ගානේ තියෙන එක object එකයි. මොකද දැන් දෙන්නම එකට තමයි යන්නේ. So it's a 2m mass now. It's a 2m mass. Both will move with the same velocity. But instead of asking the common velocity of both, they're asking what is the velocity of the first block after the collision. ඉතින් බලන්න මෙතන කෙලින්ම අපිව රවට්ටන්න හදලා තියෙන්නේ. ඉතින් perfectly inelastic collision එකක් කියලා කියන්නේ මොකක්ද කියලා දන්නේ නැති කෙනෙකුට මේ අවුරුද්ද මේ ගාන හදාගන්න බෑ. Right? So that is why you need to know perfectly what these three collision types are. Fine. So now we know that this is a perfectly inelastic collision. So we know that they both move together. හරි. එහෙමනම් දැන් අපිට පුළුවන් මේකට conservation of linear momentum apply කරන්න. So we can say applying conservation of linear momentum. තාපොඩි tip එකක් දෙන්නම්. Now most of the times they have given in bold letters in this type of question. හැබැයි ඒකෙන් අදහස් වෙන්නේ හැම question එකකම තියෙන critical point එක පුතේ අපිට highlight කරලා පෙන්නනවා කියලා. එහෙම වෙන්නේ නැහැ. ඉතින් අපි කරන්න ඕනේ මේ තියෙන critical points ගාන කියවනකොට අපි ඒවා highlight කරගන්න ඕනේ. ඉතින් හොඳම දේ තමයි pencil-ක් අරගෙන ගාන කියවද්දි මේ ටික highlight කරගන්න. මොනවද critical points? Because each and every word in every question is very important. සමහර වෙලාවට ගාන වර්ධිනවා අපි එක වචනයක් හරියට කියවලා නැහැ. කියවලා සමහරලාට ඒක තේරුම් අරගෙන නැහැ. So every word in every question is really important, so you better highlight them. Okay. So we apply conservation of linear momentum towards right hand side. M into 2v plus again m into v is equal to 2m into u. So we can see that m get cancelled. So here we get 3v is equal to 2u. So u is equal to 3v by 2. So here we have the answer. It is not just the velocity of the first block, it is the velocity of both of the blocks. So the answer is the fourth one. කලින් එකේ fourth one, මෙන්න මේකේ fourth one ආවා අපිට. හරි පුතේ. දැන් we have discussed about collisions. So දැන් අපි collisions ගැන කතා කරා. දැන් අපි කතා කරේ නෑ හැම question type එකක්ම. Right? You know that we couldn't discuss all the types of questions. We just discussed like two questions. Questions දෙකයි අපි කතා කරේ. Right? So what we wanted to do is that we wanted to talk about collisions and we wanted to talk about these three collision types. Right? So I think that you have understood how these three types of collisions work. And also, if you want to check these collisions of the identical masses එකට හැපුණාම මොකද වෙන්නේ? අපි හොයාගත්තා එකක් අනිත් එකට totally යාගේ momentum එක transfer කරනවා කියලා. මේක බලා ගන්න device එකක් තියෙනවා. Right? This is called Newton's cradle. Newton's cradle. So if you type Newton's cradle on YouTube, you can find a lot of videos which can show exactly. You can even buy one. Right? They are available in some fancy item shops. You might have seen it. Some of you might have this. So this Newton's cradle is a device by which that you can identify, you can find the real-time example of collisions of identical masses. Right. So thank you for watching the video, right? So we'll come back with the same type of video once again, right? තවත් මේ වගේ වීඩියෝ එකක් එක්ක අපි හම්බෙමු ආයෙත්